Good morning to all of you. Today I'm going to start Unit 1 of second year. Unit 1 of second year is waves. Before going deep into the subject, I want to discuss about important topics of this lesson. If you have good foundation of these topics, what I am going to teach you now, at that time you will get good knowledge in this chapter. Let me discuss about the important topics about this lesson. Important topics. Important topics. So, first important topic is actually waves. You are going to read about waves. So, we should know actually what is a wave. What is a wave? So, you see, when you drop a stone in a still water, at that time you see the water is disturbed. So, water is disturbed. At the time it is moving from center position to in all directions, it forms a circle and you will see as if the water is moving. So water consists of particles, matter is of three states. One is solids, liquids and gases. Till now you know that one. Okay, extra states also there, but for us three states. One is solids, liquids and gases. So we think that the water is moving. We think the water particles are moving. Did you observe any time? Yes. So when you drop a stone in a still water, in a pond or in a lake or in some other tub, tub of full water. So if you drop a stone in that one, the water moves in all directions, forming a circular path. So at that time, what do you think? The water is moving. But actually, the water particles don't move. Only the energy moves. Only the energy moves. Energy of the particles moves. So there is only disturbance in the energy. Okay, particles won't move. Whatever the particles, matter won't move. Particles are present in the matter that won't move. So what does a wave mean? Wave is a disturbance produced in a matter. Wave is a disturbance produced in matter which move without the actual physical transfer or flow of matter has a whole are called waves. Try to understand me. Before I told you clearly, now I am telling the definition. So particles move kavu, only energy matrame move aitadi. So particles move kavu. Okay, dentlo wave ane dantlo particles ane move kavu. There is no physical transfer. There is no physical transfer. Only energy transfer is there for that one. Let me write about the definition of a wave. Okay, what is a wave? I am writing here. What is a wave means? Wave is a disturbance. Wave is a disturbance produced in a matter. Wave is a disturbance produced in a matter which move without without physical transfer of matter, physical transfer of matter means it moves what that it is appearing as if it is moving. Only energy is moving, only energy of the particles is moving, but no physical, no, in that matter is not moving. Particles are not moving in the matter, only the energy is moving. So wave is a disturbance produced in a matter which move without physical transfer of matter is known as wave. Okay, did you understand clearly? Yeah, I will show this video, okay, in future class, next class. Okay, what's happening if you drop a stone, what the transfer, how can you say that only the energy is transferring, not the particle is transferring? Okay, I will show that clearly in the next video. And this is about the wave. Next important is mechanical waves. What is that one? Next topic is mechanical waves. Mechanical waves. Okay, there are two types of mechanical waves. Already you know, you have read them in your previous classes, maybe 8th, 9th or 10th class. So mechanical waves, there are two types. One is transverse and another one is longitudinal. One is transverse wave, one is longitudinal wave. Okay, transverse progressive wave and longitudinal progressive wave. Okay, so mechanical waves are of two types. One is transverse wave and another one is longitudinal wave. Okay, one is transverse wave and another one is longitudinal wave. Let us discuss now about the transverse wave. Let me discuss about the transverse wave. What is the transverse wave? If the constants of the medium oscillate perpendicular to the propagation of the wave, is said to be transverse wave. Try to understand me. Okay, if the constants of the matter, if the constants of the medium or matter or medium, whatever it may be, if the constants of the medium means in medium some particles are there, they will be moving. Okay, like this. If the constants of the medium are moving, okay, if the constants of the medium are oscillating, how they are oscillating? So the propagation in this direction, this is the propagation. Propagation means it is propagated and moving in this direction. So propagation means moving. At that time, if this wave is there, this is propagating in the forward direction. This is propagating in the forward direction. What is telling? If the constants of the medium oscillate perpendicular to the propagation of the wave. This is perpendicular. These are perpendicular. This is perpendicular. So These are all propagating in perpendicular to the propagation of the wave. Okay, this, if you take this one, this is perpendicular to the propagation of the wave. This particle is propagating perpendicular to the propagation of the wave. So actually the wave is moving in this direction, propagating in this direction. The particles, whatever the particles are there, they are perpendicular. See, if you take here the particle, if you take here particle, here particle, here particle of the medium, that is perpendicular to the propagation of the wave, then that wave is said to be the transverse wave. Okay. If the constituents of the medium oscillate, perpendicular to the oscillating, here you see it is oscillating first above this one, then afterwards below, then afterwards above, but they are propagating perpendicular to the movement is like this. The wave movement is in this direction, but the whatever the medium particles are there, they are propagating above and below perpendicular. Okay, perpendicular. That kind of wave is said to be the transverse wave. Okay, that's it. This. So I'll write here. What is that one? So transverse wave. Okay. Transverse wave means what? What did I tell you? Once again, you revise. I think you are written. Come on, revise it. If the constituents of the wave, if the constituents of the medium propagate, constituents of the medium oscillate, if the constituents of the medium oscillate, perpendicular to the propagation of the wave, then that is said to be the transverse wave. Okay. If the constituents of the medium oscillate perpendicular to the propagation of the wave, then that wave is said to be the transverse wave. Did you understand? The wave, so the figure is like this. So the medium, if this is there, this is the wave. Whatever the particles are there, this is in the medium, they are oscillating perpendicularly to the propagation of the wave. The wave propagates in this direction. This is the wave propagation movement, and this is oscillating perpendicularly. Okay, this is oscillating perpendicularly to the propagation of the wave. Why I am repeating these many times means you should understand clearly. Okay, you should understand clearly. I'm not leaving by telling once. Please try to understand. So the repetition will impact your brain. That's why I'm repeating each and every time. Please listen clearly and try to understand clearly. So that is oscillating perpendicularly to the propagation of the wave. Oscillating perpendicularly like this. Okay, this is oscillating up and down, up, down. So that is propagation is in this direction. Oscillations are in this direction, perpendicular. Perpendicular means having 90 degrees. This is the wave propagation. This is the wave propagation. Okay, and wave is oscillating like this. Okay, wave is oscillating like this, perpendicularly. Wave is oscillating perpendicularly. That is said to be the transverse wave. Okay. Yeah. Then afterwards, longitudinal wave. So longitudinal wave. Longitudinal wave means quite opposite to that one. What is that one? What is that one? Okay, try to tell yourself only what is that one. Actually, what is transverse wave? I told, if the constituents of the medium, okay, if the constituents of the medium are, okay, moving perpendicular to the propagation of the wave, oscillates perpendicular to the propagation of the wave, then those are said to be transverse wave. But longitudinal waves were what? Whatever this longitudinal waves are there, they will move in the direction of the propagation of the wave. They move in the direction of the wave. That is, if the constituents of the medium, if the constituents of the medium are in the direction of propagation of wave, then that is said to be longitudinal wave. Okay, did you understand? So if in that particles are there, in that matter is there, no, this whatever in matter only this waves are created. So if the constituents of the medium are in the direction of the propagation of the wave, they are in the direction of the propagation of the wave. They are not moving perpendicularly, they are moving parallelly. Okay, in the direction of the wave means in the direction, the same direction means parallel. In the same direction means parallel. So I'm rubbing it fastly, but you pause the video and write it down clearly in your notes. Please maintain a good notes for you. Okay. So you see here, this wave is in the propagation of that wave. So the particles, the medium is in the direction of the propagation of the wave. How the wave will be? It is propagating like this. Okay. Okay. The wave is propagating like this. The propagation is like this. It is in the direction of the propagation of the wave. See, here this wave is moving in this direction only. Before you have seen, the wave is moving like this. Means it is propagating up and below, up, below. But this is moving in the same direction of the wave. This whatever the medium is there, that is oscillate, the particles of the medium are oscillating in the direction of the wave, then that is said to be longitudinal wave. Do you understand? Yeah. Please read them clearly, understand them clearly, so that you will have good good knowledge. You will get good knowledge to go deep into the subject. Then the topic is, here you learned about waves. You learned about different waves, but in that different concepts are there. What are those? One is, first you discussed about the transverse wave. What is one? So transverse wave is what? The constituents of the medium propagate perpendicular to the direction of the wave propagation. The constituents of the medium propagate perpendicular to the direction of the wave, perpendicular to the direction of propagation of the wave, that is said to be. But here in this transverse wave, you have upper oscillation, lower, upper, lower. Okay, that in the propagation. So this is known as crest, and this is known as trough. And from here to here, this is known as amplitude, Okay, from this point to this point to this point, or from this point to this point, it is known as wavelength, or from this point to this point is known as the wavelength. Okay, from this point to this point is known as wavelength. From crest to crest, or from trough to trough, that's known as wavelength. Okay, this is the wavelength. These are all topics you are going to learn now slowly. So let me teach that one. What is a crest? What is a trough? Okay, consider a transverse wave. Consider a transverse wave. I'm considering this. This is a transverse wave. Try to draw yourself the figure. Like this. Okay. So let me discuss about crest and trough. This one is known as crest, and this one is known as trough. This one is known as crest, and this one is known as trough. Okay, this one is known as crest. Upper part of the oscillation is known as crest, and the down part is known as the trough. Try to remember like that. This upper one is known as crest, and this one is known as the trough. Okay, crest, trough, crest, trough. Okay, did you understand? Okay, the distance between these two, the distance between this point and this maximum point, are from starting point to starting point. Okay, the distance between two successive means pakka pakkana anardham, side by side anardham. Two successive crests is known as wavelength, or the distance between two successive troughs is known as wavelength. Okay, the distance between two successive crests is known as wavelength. The distance between two successive troughs is known as wavelength. You take the point here, or you take the point from here to starting point of here. Nothing will happen. Okay, this is the starting of crest. This is the starting of trough, and this is the midpoint of crest. This is the midpoint of crest. This is the starting point of crest. This is the starting point of next crest. This is the middle point of crest, and this is the middle point of crest. ఇక్కడ నుంచి ఇక్కడి కన్నా లేకపోతే స్టార్టింగ్ పాయింట్ ఆఫ్ క్రెస్ట్ నుంచి నెక్స్ట్ స్టార్టింగ్ పాయింట్ ఆఫ్ క్రెస్ట్ కన్నా the distance is known as the wavelength. But the distance is known as wavelength. So I can define wavelength as what? Wavelength. The distance between two successive crests, or two successive troughs, is known as wavelength. Is known as wavelength. Okay, this is known as the wavelength. Okay, the distance between two successive crests or two successive troughs is known as wavelength. Is known as wavelength. The distance between two successive crests or two successive troughs is known as wavelength. Okay. క్రెస్ట్ మధ్యలో క్రెస్ట్ దాని పక్కన క్రెస్ట్ మధ్యలో ఉండే డిస్టెన్స్ ని వేవ్ లెంత్ అంటారు. లేకపోతే ట్రఫ్, నెక్స్ట్ ట్రఫ్ మధ్యలో ఉండే డిస్టెన్స్ని వేవ్ లెంత్ అంటారు. ఓకేనా? Did you understand clearly? Next one is, okay. From here to here, that is the height of the oscillation. The type of the height of the oscillation is known as amplitude. The height of the oscillation is known as amplitude. Amplitude. This is known as amplitude. The height, the maximum height of the oscillation is known as amplitude, or the maximum height of crest or trough is known as amplitude. The maximum displacement of crest or trough is known as the amplitude. Okay, did you understand? This is, you consider, for amplitude, that can be represented with small a. Here also small a, but it is in the negative direction, that's why it's in minus a. Okay, but the maximum displacement of the crest or the maximum displacement of the trough is said to be amplitude. Okay, amplitude. That is, we define amplitude like this. And what is amplitude? The maximum height covered by a trough is known as amplitude. That's known as the amplitude. Okay, understood? This is the amplitude. Next topic is longitudinal waves. In transverse waves, crests and troughs are formed. But in longitudinal waves, what are the names of those? Compressions and ray refractions. Compressions and ray refractions. Why compressions? It is like a spring. So, this can be observed in sound waves, longitudinal waves. Okay, sound waves, those are. So, you can observe these longitudinal waves in sound waves. Okay, so that sometimes compressions are there. This is compression. In that a crest and trough is there, no. But in this, compressions and ray refractions. Okay. This is compression. If you think this is as compression, and okay, this has ray refractions. Once again, ray refraction. Once again, compression. Like this. So here you can observe. Here compression is the compression అంటే చాలా దగ్గర ఉండేదాన్ని కంప్రెస్ చేయడము అంటే చాలా దగ్గరికి చేయడం కంప్రెషన్. This is rarefaction. This is compression. This is rarefaction. This is compression. Compressing. Compress. Compress అంటే ఒత్తిడిగా ఉన్నాయి. ఇవి దూరం దూరం ఉన్నాయి. ఇవి ఒత్తిడిగా ఉన్నాయి. ఇవి దూరం దూరం. ఇవి ఒత్తిడిగా ఉన్నాయి. So this is compression, rarefaction, compression, rarefaction, compression. This is known as compression. This is known as rarefaction. This is known as rarefaction. Once again, this is known as compression. This is known as rarefaction. Rarefaction. Okay. The spelling I'm right here clearly. Compression. C-O-M-P-R-E-S-S-I-O-N. Rarefaction. R-A-R-E-F-R-A-C-T-I-O-N. Okay. Compression, rarefaction. You will observe these in longitudinal waves. In transverse waves, what do you observe? Crests and troughs. Okay. These compressions and rarefactions are in the direction of the propagation of the wave. Crest and trough are perpendicular to the propagation of the wave. Crest and trough are in the perpendicular direction of the wave. And this compression and rarefaction are in the direction of the wave. Okay. Did you understand clearly? Next one is okay. Did you note it clearly? Yeah. So here also wavelength you can define here. How can you define the wavelength here? The distance between the two successive compressions. The distance between the two successive compressions is known as wavelength. The distance between two successive rarefactions is known as wavelength. Please write it yourself. The distance between two successive compressions or the distance between two successive rarefactions is known as wavelength. Okay, good. Then here also we can define amplitude. Amplitude means maximum displacement of the wave. Maximum displacement of the wave is said to be the amplitude. Maximum displacement of the wave. How I define in transverse waves, the same definition comes here. That is, the maximum displacement of the wave is known as amplitude. Okay, that's it. These are the topics for today. You go them thoroughly. Okay, you revise them thoroughly. Okay, so that you'll have good foundation for waves. Why I'm teaching this one slowly means that whatever my teaching is, that should impact your brain very clearly and effectively. For that I am teaching very slowly, and if you go through my subject clearly, whatever the important topics I am teaching in the before starting of my regular chapter, that will give more knowledge about the chapter, and it is good for you to learn these topics. Okay, that is for today. Thank you very much.